Okay, good afternoon, everyone. Hope everyone has joined. Can you hear me?
Yes, madam.
So, how about the others? Only 65 people are here. So, let's give them some 1 or 2 minutes for them to join and let them know we are in the lecture. Okay, let's start ourselves. So far in our numerical analysis section, course, we have finished, I guess, our chapter 1 and 2. Okay. Actually we have finished in the sense, but yeah, it is there are something we have to talk about the linear difference equation of first and second order. Okay, so that is also coming for again for the forward and here also. So I would like to continue as chapter number 3, and I will discuss here as well the same thing, so no need to worry. Okay, so anyway, I would like to first of all, have you tried the homework quizzes number 3 or 4? I have sent you yesterday. Did you find a time to find the answers? Can you answer me? Did you go through the questions and can you find all the answers for all the questions? Hope it is covering full of chapter number 2. Okay. So try to, yeah. So I want you to check all the questions and see whether you can answer. So because to make, okay, only one person answered yes. Yes, the others. Don't you even see the questions? So it is covering all the sections of, chapter number 2. So it is very, it will be easy like how we study in our courses. From that you can find the definitions, and then everything we have studied already. Only thing is you have to find the answer for the questions. So if you are good at it, it is okay. It is our question number 2. Question number 2 of our semester, as well as the um, continuous assessment number 2 type of questions. Okay. Similarly, I have sent you for the chapter 1 as well. So far we have come to half of our course, hopefully. Okay. So that's that. I will find the, I will ask you the questions from the quizzes today. So let's see how much you have go through the things. Okay. Anyway, I would like to start today's lecture by chapter number 3. Okay. We can also talk something about this left out difference equation things also. Okay. So let me take some a second. Okay. So in that chapter, so it is linear difference equation. Difference equations. So earlier in our like EDE and things, okay, elementary difference equation, also you are studying now ODE. On that things you have studied about differential equation. Okay, differential. So you have to know these two are two different concepts, not same. Okay. So this is a differential equation. This is a difference. So what do you mean by difference? So for example, if I say, let's say this is my point A, this is my point B. What is the difference between these points? Can you answer me? I don't want only one person to answer. I need everyone to answer, and I also will check your attendance as well. Okay. Yeah, good. You got the idea. So difference mean the difference between these. Okay. So B minus A. Like that, for example. So what is the concept of, okay, linear finite difference equation? For example, okay. You may heard, this is a different concept. Okay. We are not going to go here. This is something else we have studied and you are studying. That is different things. Okay. So I'm just wanted to tell you to show you these two are different case. Okay. So I'm not going to talk about this one. I'm going to talk about this difference equation. So you have to know, um, this is talking something between the differences between the points. Okay. Even in some concept like finite difference. That's how it says. Okay. So this is also chapter number 3 as well as chapter 2 last part. Okay. So I'm still on the chapter 2 last part. Okay. Finite difference in the sense we have studied two different ways. For example, Newton has found some method, which is Newton's, we say forward differences as well as Newton's backward. Okay. So you know what it means, isn't it? So forward means we go from A to B. This we called as a forward. Let's say backward, for example, okay? For backward means B to A in this side, okay? So in that sense, it is, we are finding the differences, okay? And also, what do you call finite points? For example, let's say I have some finite, this is like we have seen in our school days. For example, let's say my x is equal to, I can choose any numbers, isn't it? For example, x naught, okay, x1, x2, something numbers, okay, xn, maybe any number, 0, 1, 2, 3, or 0, 5, 10, 15, 20, like that, okay. And then I have a function y, which is a function of x, okay. For example, let's say my function is x squared minus 2x plus 5, something a function of x, isn't it? So whenever I put these discrete finite points, okay, these are called as a finite points, isn't it? So in this, when I putting these different finite points, according to that, my y function of y is equal to f of x, x also will change, isn't it? So that kind of concept is coming here. And then, okay, can you take down the notes as well when I'm talking, okay? Keep some roughs and notes with you. Whatever I'm talking, please write down, okay? I need to erase quickly, so that's what I'm talking, okay? So I will be erase quickly, so okay. So that sense, let's say my points are x and y is equal to f of x. For example, let's say 0, 1, 2, 3, 4, let's say. So let's say my f of x equal to x squared minus 5x. So can you find the points of y? What will be the values of y? Can you check or can you type and send me just for a introduction? So what will be the y points? Please send the answers. So this is a generally, okay? Generally, let's say my index, 0 index, my point x naught, and this will be my y naught. Y naught is equal to, we can choose x. This is xi, and this is yi of fxi, okay? So y naught will be f of x naught, okay? Similarly, if x1, so my y1 will be f of x1, okay? According to the points, okay, discrete finite points, my value is also changing. This will be xn, so yn will be f of xn, okay? So in this point, we have to put the accurate discrete points to find our functional value, okay? So this is not a big thing anyway. Okay, some has sent some answers. Okay, so correct. 0, -4, -6, -6, -4. I didn't check, but anyway. So if everyone, okay, you are getting different answers, please check your answers. Give me a second. Okay, so for example, if I put 0, it will be 0, isn't it? If I put 1, 1 minus 5, which is equal to -4. If I put 2, this will be 4 minus 10. This will be -6. If it is 3, 9 minus 15. This will be -6. Yes, 4. Then 16 minus 20 is -4. Okay, this just for the exercise, okay? So you got the idea. So what I wanted to tell you is, so let's say my index point at the 0 point, my xi will be x naught and my yi will be, it will be counted from the f of xi, okay? According to the function, we can find the y, okay? So y naught. If it is index 1, x1, y1, like that, end point xn, y. So we have some finite points, okay? So let's say, okay, I will take to the next window, okay? Okay, let's say, so this is my x's, okay? X naught, x1, x2, okay, xn. According to that, I'll have some yi, okay? This will be y naught, y1, y2, up to yn, okay? So what do you think these differences? X1, for example, let's say my interval will be a comma b, okay? Let's say 0 to something 10, okay? So I need to divide these according to some interval. Let's say my x1, this is my x naught, no? X naught. Let's say this is my x1. So what will be the difference between these x values? Difference between the x values. Can you tell me this difference between these two values? What is the difference? For example, let's say x naught is equal to 0. X1 is equal to, let's say, 2, something. Okay, how we find the generally how you can write there? Yes, good. So this will be correct. So we are taking from x1 to x0, isn't it? This one, similar way, isn't it? X2 minus x1. But what do you think about x2 to x0? So let's say this is my h. First of all, I'm taking the, differences as a equal one. Okay, let's say all the like 2, 4, 6, 8, 10, like that. Okay, only my h will be 2. Okay, all are like in a sum, we called as common difference. Okay, common difference. It means difference are equal. Okay, or equal difference, equal differences or common differences. So they have a common differences between the x values. Okay, so what do you think x2 according to x0? X0 plus what? Let's say how many, see here, this is my x2, isn't it? From here to here, how much they have deviated? How much differences we have? There are two, no? So you can give the answer. Tell me the answer for this blank. What will be the answer? Let me check. I want everyone to participate the answering questions. Okay. Yes, good. Yeah. 002. Can you check your answers? Don't think much. Just yes, you have written this way. Okay, that's fine. But I'm asking in terms of h. Okay. So for a common one, okay, let's say x1 will be x naught plus h, isn't it? Similarly, x2 can be, if I'm taking from x naught, there are 2 times h, isn't it? So like that you can write. How? What about xn? From x naught to how many h they have deviated? Yes, good. So we know n times h has been deviated to the nth point, isn't it? Yes. So you get the ideas. This is about the difference of x. Okay. Um, it can be even, sorry, equal differences or unequal. Okay. There can be some situation we can see later. Okay. But even though equal or unequal, they may give you in the data set. First of all, even like as a stat people or any other courses, they will give you the x, isn't it? In a school time also, when we draw some graphs and all, okay, they will give you x. They will give you the function of fx, and then they ask you to find the y naught. Is that should be any equal equal differences in between these two? These y's, y can be changed according to the f of x, isn't it? So no need to be equal or other things. Okay, sometime it may be, but not always. Okay, so this is x differences can be divided into two cases, equal and unequal. But actually here we are talking about finite difference. Okay, it's not talking about the x difference, it's talking about the y difference. Okay, all right, so we have seen, okay, two ways finite differences. So I use, okay, I'll take the other window. Okay, let me take finite differences. I'm using the abbreviation anyhow. You know the things. So finite difference. So we have seen two cases, forward and backward, isn't it? So for the forward, for the differences of finite difference itself, talking about the yi differences, not about the xi. Okay, yi is our solutions now. According to that difference only, we are talking here. And then it talking two different ways of differences. Okay, so one is we call forward. Forward we use this notation, we call delta. Okay, it's called a delta. Similarly, backward we use this notation. So you have to be careful. If it is one, one edge up, we call delta. That is we use for forward. So this will be one edge will be downward. Okay, this is called a backward. This is called nebula or nibla or something like. Okay, this is this notation called as a nibla. Okay. Okay, what do you think about? Okay, so for example, as I said, x, the next point will be x plus h. The next point will be x plus 2h. Like that, we go up to, let's say, x naught, x naught, x naught, or x naught. Commonly, we can write x. Okay. So the functional value will be this one fx. Let's say this will be f plus h. This will be f plus 2h. Okay. It goes like that. Let's say this will be our nth point. Okay. X plus nh. So f of x plus nh. Okay. We also use the names y, y0, y1, y2, like that. Okay. So in that sense, okay, delta is forward one. Okay. If I use, let's say, delta of fx, which is equal to, okay, so keep in mind, delta of fx, which is equal to, let's say, for example, this is my y naught. This is my y1. This is my y2. It goes no yn. So in this, this is my f of x, let's say. This will be f of x plus h. So what is the forward? Forward means what? It forwarding. Okay. It from the initial to the end, it is forwarding. Okay. So in that sense, so what is the difference between these two? How you can find whether you take from here to here or here to here. How you take the differences? Likewise, you take the difference between x0 to x1. So x1 will be x0 plus h0. So what is the difference? H is equal to, please give the answer. What is h? What is h from this one? This is I already explained. That's why I'm asking the question from you. Okay, good. So yes, h will be x1 minus x0, isn't it? So we are taking the h from upper one to lower one, isn't it? So x1 to x0, not x0 to x1. Okay. So likewise, if it is forwarding, we have to go from here to here. Okay. Like y1 to y0, isn't it? So this is equal to f of x plus h minus f of x. Okay. So for the fx will be fx plus h minus fx. That means, for example, if I say y delta y, do I need to put 1 or not? Can you tell me? So what should I put here as a subscription? What I need to put? Is that either 1 or 0? Yes, good. So we have talked a lot of this one, no? Forward means, so fx, no? So a y delta of y naught will be, to get the difference of these two, we called as delta y naught, which is equal to y1 minus y naught. Good. Y1 minus y naught. Okay. So you have to know this one. So this is for the forward differences. Okay. What about the backward? Okay. Nebula. Nebula of fx. Can you write the answers here? And in terms of nebula y also. Can you answer this one? According to f of x, according to y. Can you answer me the nebula terms? If you need, if you can't write with me, please take the screenshot also, okay? So when you are writing the notes correctly, it will be helpful for you. Yeah, okay. Yeah, good. Getting some answers, yes. Yeah. Okay, so it means backward, isn't it? Backward in the sense, okay, nebula of y, okay, let's say f of x, it should be equal to, okay. So wherever you are taking the nebula, you have to use this and this, but for this one, you have to use the backward step. Okay. So for if you need delta of fx, for example, okay, I need to go from fx to, so if I am going from fx, okay, fx no, our function, so nibla of fx, which is equal to, let's say this is my fx. Can you write this answer only? This is, of course, difference have the negative sign, no? So subtraction we called as a, subtraction only we called as a difference, okay? So keep in mind, you should have negative here, okay? So fx minus what? If I am taking fx, let's say, what should be here in terms of fx? Yeah, okay. So can you 0, 36 and 32 and everyone? Yeah, some okay. Can you write in terms of h? Yeah, I know you got the idea, but can you write in terms of h, like a general idea? So for example, if I use my delta f of x equal to fx plus h minus fx, no? So I'm going forward, okay, from forward to the our point, okay? So if I am going backward, okay, our meeting will end in 10 minutes anyway, okay? So if I am going backward, okay, so most of your answers are correct. 0, 95, sorry, 94, 92. Check your answers, okay? So in here, since backward, you have to use here f of x minus h. Okay, the point of here. So here only now I put my fx. So I need to go this side. Okay. So likewise, if I am going other one, it goes. This is the general equation. Okay, this is a delta general equation. Similarly, this is the nebula general equation. It means nebula of f of x equal to f of x itself. Okay, wherever you are starting, you have to start from there to 1 point less. Okay, so x minus 8. So in terms of, can you write in terms of yn, what will be this? Minus this. Yeah, some have written the answer f x plus h. Please correct your answers, okay? This should be x minus h, okay? F of x minus h. So what will be this questions? Okay, yeah, good. So if I am telling yn, okay, this should be yn, of course. So 1 less than that, no? So it will be yn minus 1. Please keep it in your mind. Some are confusing this h regarding the fx minus h. But when you are using y, we don't use the h, no? So you should know this h depend on the x values. X values, wherever you are having the function of f only, you have to use, okay? X difference. So here in this equation only we are using h and all. And here we are making it y I is equal to f of xi plus ih. Okay, in that sense, we don't have sorry, h values in these points. Okay, only x term will be increment or discrement by h. Okay, so some have used the yeah, yn minus h. Please check your it should be yn minus 1. Okay. Okay, I will do again as a summary. Okay, so we have if you have some points, x points, you can find the f of x according to the functional value, and then these differences h, sometimes all are common differences. Sometimes there may be, for example, if I have 1, 2, 3, h will be 1, no? Let's say I can take this one also, no? 5, 7, 13, 21, like that, some discrete points. So these are my x values. So h may be different, no? So this will be equal differences. There may be unequal as well. Okay, unequal situation may come. Okay, so according to that, we can find our f. If we know the f of x, we can find the value of y. Okay, so in these differences, okay, so we have two differences. One is forward. So find a difference in the sense we have forward and backward. So backward. Okay. So forward we use the delta notation. Delta notation means delta of yn is equal to yn. So if you're starting yn, you have to include one more. Okay. Then this one. So this yn goes to this side. Okay. But the backward yn, which is equal to yn itself, you have to take one less than that. That is the only difference between these two. Okay, all the other calculation things and everything are fine. Okay, same. Okay, now I'll continue the next window. Okay, now for example, we know how to solve these. You are studying now this one. Let's say y is equal to 0. So what kind of equation this one? Can you answer me? What kind of equation is this? Or you may have like this also. Okay. These are, yes, ODE, homogeneous. You know everything, isn't it? So you are studying this one, how to solve this, you know, using the common factor and things, okay? Particular equation and all these things, okay? So you know how to do this one, no? Okay? So likewise, so this is not what we are going to study here. So if you have like this, for example, if y, let's say yn plus 3 is equal to 0. So what kind of equation this one? We don't have dash or dot and anything. So it's not a differential equation concept. But what is this one? What is these notations are used for? Answer me. What kind of equation I said you? At first I said you. Yes. No. Yeah. Good. So no need to think talk about forward or backward. This is a difference equation, isn't it? Difference. Okay. Difference equation, not a differential. Okay. So this kind of equation also can be solved by the method of like this method. Okay. So not the same, but the same method. Okay. So which is also have some initial condition. Let's say, for example, yeah, y naught is equal to, sorry, y naught is equal to 2, y1 is equal to 1, then solve this. So this is called, okay, we here also we can have some order, okay, some degree and solving processes, okay, and initial value problems. Okay, this is what our section number two things. Okay, but for time being, I'm just skipping this one, but it is for your exercises for now. Okay, because you are studying ODE, this will be very easy for you. Okay, so only thing is you have to find how to solve this one and find the order, find the degree, find the solving methods, solving things, and initial value problem, how we can solve and all. Okay, this is your exercise for time being. Okay, so if we got some time, extra time, we can study this one. But if you are not study anyway, it will be like assignments or anything, right? So it just better you know these things. Okay, so you have to search for For what that is our linear first order, first and second order finite difference. Okay, equation solving methods and things. Okay, so this is your exercise. Okay, for now. So I hope you can study this one. Okay, so this is your exercise section. Okay, so I will expect you some. I will give you some. I mean, in the exam or anything, I will ask you some questions. So it's your things. Okay. So try to find the solutions. So give me a second. So in this, you can have this as a, finite difference. Okay. So our session should, I'm gonna finish. Please join again. Okay. Linear finite. Search around this one. Okay, and study yourself. Difference equation of first and second order.